Hello friends, I haven't uploaded any video since 1 month. Sorry for that. Okay. From now we will continue our study. So in our previous video we will cover classful IPv4 address. There are 5 types of IPv4 address classification: A, B, C, D, E. Now today we will see subnetting. In subnetting, we divide a network. We divide a IPv4 network into logical. It is a logical division of a network into smaller manageable subnetworks. Okay. तो क्या है कि जो हमारी IP एड्रेस है, so we divide our IPv4 address into small parts in which the network ID part is as it is, but the host ID part we divided into 2 parts: subnetwork ID and host ID. Okay, so here we see that subnetwork or subnet, clustering of the host inside a network. Means there is a network, we have the network ID and the host ID. Means that we cluster the networks. We cluster the host on the base of the subnetwork. Okay, you will understand it later carefully. Okay, clustering of the host based on the some bits of host identifier field. Okay, we will say that here before subnetting, what is the IP address? There is 2 parts of IP address: network identifier and host ID part. In network ID is X bit and remaining bits is Y bits host ID. So the size of IP address is X plus Y bit. This is before subnetting. But after subnetting, what happens? After subnetting, here is the network ID and the subnetwork identifier. The network ID is as same it is before subnetting, X bit, but the subnetwork is created from host ID field. So the host ID subnetwork field is Y bit. So the host ID field is by 2 minus. So the host identifier is host ID is Y2 bit. So Y1 and Y2 is equal to Y1, Y2 is equal to Y before subnetting. Okay. Then subnetting is created from host ID field. Network ID field is as it is in previous before subnetting. Size of IPv4 address. So after subnetting, the size of IPv4 address is X plus Y1 plus Y2 bits and Y1 and Y2 bits. So the before subnetting, network ID field and host ID, but after subnetting, network ID and host ID is divided into 2 parts: subnetting and host ID. So the subnetwork address, special IP address, 32 bits, subnet address. Okay, so the special IP address of 32 bits used to represent subnetwork. So here the network ID field is same as it is assigned, but the subnet ID anything and host ID field be all 0. So here so there in subnetwork address, network ID field, subnet ID and host ID. As we see in network address, what we see in network address ID is assigned by the network ID is assigned by the service provider. So as it is, and host ID is all zeros for network address. But in subnetwork address, network ID is same, provided by the service provider. Host ID is all zeros, but the subnet ID is as per our. It will be anything. Okay. Subnetwork broadcast address. In subnetwork broadcast address, the network ID field as it is, provided by the service provider, and subnetwork ID is anything, and host ID will be all 1 bits. Okay, so the host IP address, network ID field, subnet ID, and host ID. The host ID must be accept all 0 and all 1s. So here the main important part is size of subnet. So subnet size, maximum possible number of hosts can be in any subnetwork. Okay, let's see here. If the IP address is 32-bit, so if there is a X bit network ID and by 1 bit of subnet ID and the by 2 bits of host ID, so the subnetwork size is 2 to the power y2 minus y2. Why be minus 2? Because the starting and ending 2 IP address are special IP address, so we can't use it. So here host ID is by 2 bit, so 2 to the power y2 from the v minus 2 IP address, we will subtract 2 IP address because those are the special IP address. Okay, so the number of subnets here, number of subnet. So we have created subnet from by 1 bits, so the number of subnets is 2 to the power by 1. These are the subnets. Now the size of network, maximum possible number of hosts can be in any network. So if there is a 2 to the power by 1 subnetworks, 2 to the power by 1 subnetworks into number of hosts per network. So per network, how many hosts? 2 to the power minus 2 after removing its starting and ending IP address. So this is a formula for network size. Reduction in network size, as here the some reduction of network size after creating subnetting, because if we create a subnetting, then there's a multiple networks. We create a subnetworks. In subnetting, we create from one network we create a multiple subnetworks, and each subnetworks have 2 special IP address which we can't use for host IP address. So from each subnetwork IP address, starting IP address and ending IP address are not useful for us. We use only between IP address. So there is a reduction in network size. So the size of network size before subnetting, y1 or y2, these are the before subnetting, y1 plus y2, which will equal to host ID bits. So the networks per host. After subnetting, the formula becomes this: 2y for subnetwork, and each subnetwork has host per network. So after getting the formula and subtracting the value, we get this answer. Means 2 to the power y minus 2 to the power by 1 plus 1 minus 2 host per network. The reduction in network. Now the subnetwork mask. In subnetwork mask, we have seen that in network ID fields, in subnet mask, all bits are 0, all bits are 1. For network ID field, all bits are 1. The same in case of subnet ID. Subnet ID, all bits are 1. And host ID, all bits are 0. Nothing different. Okay. Here we will take one example of class C network. In class C network, we see that there is a 24-bit network address. 24-bit network address. So the network address is this. This is a network address, and broadcast address. All bits are 1. So network address plus host address, host ID. All bits are 1. So there is 255. Now the network mask. This is a network mask. Before subnetting, here the first IP address is this. This is your network ID and this is your first network ID. Sorry, first IP address. After removing special IP address. Okay. So the last host IP is 254. You must remember 255 is a special IP address, and this here 0 is a network address. So between them, first IP address and last IP address. After removing first IP address and last IP address, we get the first host address and first host IP address. So the network size is 2 to the power 8 minus 2, 252 host per network. In class 3 subnetwork, class 3 network 254 host per network. After subnetting, after 3 bit of subnetting, means that if there is 8 bits, they said there is 8 remaining bits for host ID. Out of 8 bits, we reserve 3 bits for subnetting. We do 3 bit subnetting. So after 3 bit subnetting, there is 5 bits for host ID. Means number of hosts reduce. Because we have created a 3 bits we use 3 bit for creating a subnet. So the first host IP address is 1. Placing 1 here because these 3 bits are used for subnet. These are host ID field. If we take here 0, then it becomes a network address, subnetwork address. But after we do here 1 because we need of host IP address. And you must remember the first and last IP address is a host IP address. These are two are special IP address. One for network address and the other for broadcast address. So the last IP address is all ones except the last one, because if we do last one, then it becomes a broadcast address. So the subnet broadcast address is subnet broadcast address. Broadcast address, all host ID field are ones. Okay. The same thing here. First subnetwork, this. First IP address, this. Last IP address is this, and first subnetwork baud address, this. So here 3 bits for subnetwork. From these 3 bits, there is a how many possibles? 2 to the power 3. 8 possibles are. From 3 bits, there is a 8 possible combination are. 8 combination are possibles. So first combination 0 0 0. All 3 bits are 0. So their first network is this. First IP is this and last host is this. So in last subnetwork, so here the last subnetwork address is 3 bits 1. First IP address after all 3 bits of subnetting, place 111 means last subnetwork address. From 0 there's a from 0 means that if from 3 bits there's an 8 combination. The first combination is 0 0 0 and last combination is 1 1 1. In between them there is a 6 more combinations, but we take only first combination and last combination. Okay, here the subnetwork mask. Subnetwork mask after 3 bits of combination, all bits are 1. These 3 bits are 1s. So here is a 2 to 4. Subnetwork size is 30 hosts per subnetworks. So there is a 5 bits. Out of 5 bits, 2 to the power 5 is 32 minus 2 is 30 hosts per subnetwork. Network size 240 hosts per network. Reduction in network size is 14. This means there is a reduction. Means before subnetting there is a 254 number of hosts, but after subnetworking there is a subnetting. There is a 240 host. So there the reduction of network size is 14. Okay,